Welcome to the virtual classroom of Chem-based School of Chemistry. Today's discussion will be the paper 1 of the 2022 January Unit 1 Edexcel chemistry paper. In fact, this paper was released a few weeks ago, and please note that this point of discussion of this paper, the marking scheme is not yet released by Edexcel. Right? You can download this paper at www.chembase.lk. You can visit my website, this specific website. Under the materials, you will be able to download the latest papers. So let's begin the discussion with the section A of the paper 1, which is the MCQ section. The question 1, element X is in group 2 of the periodic table and element Y is in group 7, and X and Y are not symbols of the elements. What is the formula of the compound formed from X and Y? So the X is group 2, so X will have the valency of +2, and as for the Y, group 7, which is -1, so you know the rules of writing chemical formula. You simply cross the valencies and then you derive the formula. So the valency of Y goes into X and the valency of X goes into Y. So the answer will be XY2. Remember, when you cross the valencies, we do not include the sign, the plus and minus sign. And the plus, the cation, is usually written first when you're writing the formula, followed by the anion. So the answer for the first question is XY2. The question number 2, it is 1B. Under what conditions does the compound formed from X and Y conduct electricity? Now we know the group 2 with group 7 is an ionic compound. So ionic compounds have ions in fixed positions. They are unable to move in solid state. But the ionic compounds, the ions are mobile in aqueous or in the liquid state, which is known as the molten state. You heat and melt the substance, the ions will be mobile, or you dissolve the substance in water, the ions will be mobile. So either aqueous or in molten state, the ionic compound will contain mobile ions. So the mobile ions can carry electric current, because electricity is not just simply movement of the electrons, it is movement of the charged particles. It can be electrons, free mobile electrons, or it can be free mobile ions. So the answer for this question will be D, that is the liquid state and the aqueous state only. Question number 2, which of these compounds would you expect to have the highest melting temperature? You notice all these compounds are group 1 with group 7. So these are all ionic compounds. The ionic compounds, the melting and the boiling point is determined by the strength of the ionic bond. Now the strength of the ionic bond depends on the product of the ionic charges. Now plus, that is one of the reasons. The second reason is the size of the cation and the anion. So you know all of these are unit 1, the group 1, so all of them have the +1 charge, and the halogens all have -1 charge. So product of the ionic charges are all the same, so that cannot be used to compare. So you can compare the sizes. When the cation and the anion is smaller in size, then the attraction will be much stronger. Right, it will be having a strong attraction than the larger cation and the larger anion. Distance will be greater. So let's see which one is a smaller. We know out of potassium and sodium, sodium is smaller. Out of chlorine and fluorine, fluorine is smaller. So sodium fluoride will have a greater melting point compared to the rest of the salts. A drop of aqueous solution of green copper 2 chromate 6, right? That is Cr. This is 2 plus. Chromate 6 is 2 minus here. So chromium, this is copper, I'm sorry, copper 2 plus and chromate. So copper is blue in color, chromate is yellow in color, and the whole solution will be green as a result, because when you mix the yellow and blue together, it's green. So when you carry out electrolysis for this ion, copper 2 plus will move towards the cathode, which is a negative terminal, attracts the cations. That's why negative terminal is called the cathode. And the positive terminal is called the anode, because it attracts the anions. So you'll notice a blue color at the cathode, or the negative terminal, and the yellow color at the anode. So the answer would be D. Which of these isoelectric isoelectronic ions have the smallest ionic radius. Isoelectronic means the ions which has the same number of electrons. So the smallest ionic radii. So the nitride has two shells. Usually the cation have a smaller radii because all of these now, nitride and fluoride has two shells, and the sodium and aluminium atoms have three shells, but the ions have two shells. But the aluminium will be smaller because it has three electrons being lost, so the rest of the electrons will be strongly attracted towards the nuclei. So as a result, the atom the ion will be much smaller in size than the rest of it. So when it comes to cations, the cation with the greater positive charge, the electrons will be attracted more towards the nucleus, resulting a smaller the ion. So anions is the opposite. Anion larger radii, then that will be greater in size. Anions larger the negative charge, the anion will be larger in size. That means 3 minus is much greater in size than the F minus. Which properties of a cation results in greatest polarizing power? First of all, you need to understand what factors affects the polarizing power. Polarizing power is directly proportional to the charge. That means if the cation has a greater charge, such cation will have a greater polarizing power, and that cation can easily polarize the anion, meaning it can cause a charge separation on the anion, right? And the size. But the polarizing power is inversely proportional to the size. A cation with a smaller size, right, will have a greater polarizing power. So smaller size, greater charge will have a greater polarizing power, right? That means, say for example, you have +1 cation, larger in size, and +3 cation, small in size. So this +3 can cause a charge separation. Suppose, say this is the anion. This can cause a charge separation more in the anion than the +1 does. So when the polarizing power increases, the cation pulls the electron cloud of the anion towards itself. As a result, the electron density between the ions increase. So that favors the covalent character. When the electron density is less between the ions, that is the ionic. This is the ionic character. Both ionic compounds, but in both ionic compounds, because there is no common area between the ions. In covalent molecules, of course, you see a common area in the electron density map like this between the cation and the anion, but the ionic, you will see always a gap between the cation and the anion. So these are all ionic compounds, but this specific ionic compound, which has a greater polarizing power on the cation, will show more covalent character. That means the boiling and melting points will be low. They are soluble more in organic solvents. If ionic compounds have a more ionic character, then high boiling and melting point and greater solubility in polar solvents. That's just additional information. So anyway, which cation has a larger polarizing power? Greater charge, should be greater charge, and smaller size, smaller radius, and larger charge of the cation. But that's for the cation. As for the anion, we use the term polarizability. We don't say the polarizing power for the cation. For the anion, polarizing power is a term which is used for the cation. As for the polarizability, that is a term used for the anion. The polarizability depends on the charge and the size again. When the anion has a greater size, greater charge, that will have a greater polarizability. That means the ability of the anion to get polarized by the cation. But the anion with a smaller negative charge, smaller size, will get less polarized. So if I keep these two the anions, presence of the same cation, this can easily get polarized compared to this, because the greater the size, that means larger radius, and you should have a larger negative charge. What is the ionic equation for the reaction between aqueous solutions of barium nitrate? So barium nitrate and sodium sulfate. So let's write the equation. We get the barium sulfate and sodium nitrate here, 2Na NO3. Let's balance the equation. 2 sodium, 2 nitrate, sulfur, everything is balanced now. Let's write the state symbols. Aqueous, all the nitrate salts, all the sodium salts soluble, barium sulfate is solid. sodium nitrate is aqueous. All sodium and nitrate salts are soluble. You should know the 6 rules of solubility of salts. Then you will know the state symbols of these. All nitrates are soluble, which means aqueous, and all salts of sodium, potassium, and ammonium are soluble, which is aqueous. As for the sulfates, all sulfates are soluble except for 3 sulfates: calcium sulfate, barium sulfate, and lead sulfate. As for the chloride, all chlorides are soluble except for lead and silver chloride. And likewise, you have the rules, 6 rules of solubility of salts. You can predict the state symbols, and then once you write the balance equation, you write the state symbols with the help of the rules of solubility of salts, and then you have to break the aqueous species into ions. So barium can be broken into Ba2 plus 2NO3 minus. Only the aqueous species should be broken into ions. So these are the reactants here. And then you got the products: barium sulfate you don't break the solids, you don't break the liquids, you don't break the gases, only the aqueous you break. You have 2Na plus and 2NO3 minus. This 2 belongs to both sodium and nitrate. You can notice the nitrate get cancelled. Spectate ions, the common ions, you cancel, right? Then you get the Ba2 plus sulfate giving barium sulfate. The state symbols are important when it comes to the writing of ionic equations. Which of these molecules is not polar? Not polar. Now, carbon dioxide is a molecule which has polar bonds, but it is non-polar because the reason is it's symmetrical. Why symmetrical molecules are non-polar? Because there's negative and the positive centers exactly coincide. You can see the negative center of the 2 oxygens are on the carbon, which is positive. So when the positive and the negative centers exactly coincide, that molecule will be non-polar. That's the reason why symmetrical molecules are non-polar, because their positive and the negative centers exactly coincide, resulting no net dipole. But hydrogen chloride is polar. Water is angular. Don't forget, water, the 2 lone pairs on the same side. So positive and the negative charges. Positive end is over here. Negative end is on the oxygen. So they don't coincide, right? Even the ammonia is like that. The positive hydrogen, positive end is over here, the negative doesn't coincide. So when the positive and the negative centers do not coincide, such will be a polar. If it is coinciding, then such will be non-polar. The concentration of nitrogen dioxide in a sample of air is 0.5 ppm. What is the percentage of nitrogen dioxide molecules in the sample of air? So ppm equation, it's that's ppm is parts per million. ppm is used to represent the concentration of substances which is in trace amounts. So the pollutants, especially pollutants in a sample of water or air, is represented by this unit of ppm, not in moles per decimeter cube. That is a way of expressing the unit, the concentration in which is the substance is present in minute amount, trace amounts. So ppm equation is the volume or the mass of solute. This can be volume or the mass of solute, or over the mass of solvent, or the volume of solvent into 1 million, right? So the ppm value is given here as 0.5. So the question is, what is the percentage of nitrogen dioxide molecule in this sample of air? The thing is, we don't need to use this expression now, because we know 0.5 ppm means 1 million. If I take 1 million parts of the air, you'll have 0.5 parts of NO2. In 1 million parts of air, you have only 0.5 parts NO2. So the percentage means 100, right? If 1 million contains this much, 100 contains how much? So 0.5 divided by 1 million multiplied by 100. So you can cancel. So 0.5 divided by 10 to the power 4 is the answer. 0.5 divided by 10 to the power. So that will be 5 times 10 to the power minus 5. So 1, 2, 3, 4, 5. The answer is C. But if you need to find the mass of solute or solvent, then you have to use this expression. Ethane reacts with bromine in the presence of ultraviolet radiation. This is a free radical substitution. Ethane is C2H, is bromine, Br2. So just you are adding, remove one of the hydrogen, adding a bromine, substituting, and there will be a hydrogen halide produced as a byproduct. That's a straightforward question. Let's quickly go to the straightforward ones, but I'd like to spend more time on the more advanced questions. Easy questions we'll just rapidly go through that. Ultraviolet radiation is needed for the initiation step, which is the homolytic breaking of the halogen bond. That is to initiate the reaction. So the UV light breaks the bromine bond homolytically, producing free radicals. They are highly reactive species, short-lived. That is a driving force for the reaction. All alkanes have the same general formula. Empirical formula is different. Molecular structural formula differs. General formula of alkane is the same, CnH2n plus 2. A single molecule of decane is cracked. Which of these mixtures could not be formed? Let's see. Cracking is breaking of a long chain hydrocarbon to form more useful short chain hydrocarbons, right? So cracking is done because there is more demand for the short chain molecules than the long chain ones, because short chain molecules are mainly used for the light vehicles, but there's more light vehicles than the heavy vehicles, and also the amount of the short chain fractions produced by fractional distillation itself is not sufficient to meet this demand. That is why the long chain molecules are cracked to obtain more useful short chain ones. So decane is cracked. Usually when cracking, you get alkane and alkene. So you have a pentane. So see, pentane C5H12, pentene C5H. This is pentene C5H10 alkane and pentane C5H12. So when you add the two, you get C10H22. So you get this, right? So this is correct. The question is not formed. Ethane C2H, ethene. This is ethene C2H4, butene C4H8, and butane C4H10. Let's add all and see whether you're getting C10 and H22. This is 4 plus 4, 8 plus 2, 10. 18 plus, so this is also correct, 22, and you get propene C3H6, propane C3H8, and butene C4H8. So this is C10, and you got 20. This is 20, right? 8 plus 6 is 14 plus 6 is 20. So this is not possible. And hexene C6H12 and propane C3H8. Propane, yes, hexene and propane. This is 18, 6 plus 3, 9, right? There's 9 carbons, so it's not possible. This is also not possible. Hexene and that means we have to redo or reconsider this question. Propene formula is correct. Propane C4H8, right? Propane and butene. So 3, 3, 6 plus 4, 10, 16. This is correct because I wrote here as C3H8, but I wrote as 6 before. That's why it's not correct. So the answer is, the wrong one is D. Remember, when it comes to MCQs, go through all the answers, right? Because if in case, good that this happened, because in case if you had done a mistake, then that will be rectified, because you'll notice there are 2 correct answers. Then you will know what is the wrong answer, because some MCQs, you have 3 wrong answers and 1 correct answer. I mean, it's the other way around. Here 3 wrong, 1 correct, but there are situations you have 3 correct and 1 wrong, and they ask you for the correct one. So how can that be? 3 correct, 1 wrong, the correct one. So the 1 is correct, and that is chemistry is correct, but that is not relevant to the question. Another answer, chemistry is correct, relevant, and the third one, chemistry is correct, and that is more relevant than the previous one. It explains better the question, the answer, than the previous one. So that's the best answer you have to select. How many structural isomers have the formula this specific molecule? So we can't name the molecule unless you draw the structure, right? So you have C3H6. That means it's all 6 plus 2 is 8. So that means it's alkane, and you have the 2 chlorines. So I'm going to just put the chlorine, the same carbon, and just to save time, I'm going to put the hydrogens. You have no shortcuts here. You have to draw and see. If it's an alkene, then you can draw a cyclic one as well, because we know alkenes and cycloalkanes, they share the same general formula. So in this case, you can't do that because you can't draw the cyclic one. So you can draw three structures, right? 1,1-dichloropropane, 2,2-dichloropropane, 1,2-dichloropropane, right? This is, sorry, 2,3,1-dichloropropane, and you can draw 1,2 as well. Yes, 1,2 as well. Clear? So you got 1, 2, 3, 4 isomers. The equation for the complete combustion of hexane is shown. How many molecules of carbon dioxide are formed when 2 times 10 to the power minus 3 moles of hexane undergoes complete combustion? You have to use a stoichiometry first. Find the number of moles of carbon dioxide. The ratio is 1:6, right? 1:6. So this times 6 is the number of moles of carbon dioxide. And then the question is not the number of moles, number of molecules. So how to find the molecules from moles? You multiply the moles by the Avogadro's constant given, 6.02 10 to the power 23. You get the answer as 7.224 10 to the power 21. So the answer is B. Which pollutant cannot form when alkane fuels are burnt in car engines? Hydrogen chloride, sulfur dioxide, carbon particles, carbon monoxide, sulfur even. Sulfur can be formed because sulfur is found as an impurity in some fuels. Unless a fuel is desulfurized, sulfur is present in hydrocarbon fuel. Cannot be formed is hydrogen chloride. Hydrogen chloride is formed when plastics are burned, such as PVC. Iron 3 oxide is reduced by hydrogen in two-step process. Step 1, reduction takes place. Actually, this is Fe3 is reduced to Fe2. You can see this is 3 plus iron. This is plus 2. We'll see the reaction here produces water. That means we know for sure hydrogen is oxidized, so iron has to be reduced. So plus 3 should be reduced to plus 2. And this is the mixed oxide of iron, and that is further reduced to iron. Plus 2 is further reduced to iron. What is the maximum mass of iron that could be produced from 39.9 tons of iron 3 oxide? The first step would be to find the moles of the iron 3 oxide, Fe2O3. That is the mass in grams, 39.9. This is tons, right? So to find the moles, mass has to be in grams. Because at last the final answer is also given in tons, so you can continue in tons. But I'm going to usually it's always better to convert and find the moles, because moles is mass in grams over molar mass, not just mass over molar mass. So you have to convert this into tons, but it's not a must. And that is multiplying by 10 to the power 6. You get the in kilograms. In grams again 10 to the power 3, right? So 10 to the power 6 is to convert the tons into kilograms, because we know 10 to the power 6 is to grams, because we know 1,000 kilograms is 1 ton, right? So 1,000 kilograms, how to convert it into grams? You multiply by 1,000 again. So 1,000 times 1,000 grams is 1 ton. So simply multiply by 10 to the power 6 and the molar mass of iron 3 oxide. So here you have 55.8 times 2 and 16 times 3, which is 48. You get the answer as 159.6. So this is the moles of Fe2O3, and that should be divided by 2 divided by 3 multiplied by 2 to get the moles of Fe3O4. So that's because 3 is to 2 ratio. So moles of Fe3O4 would be this answer. This is the moles of iron 3 oxide divided by 3 to find the value for 1, divided by 3 multiplied by 2, because reason 3 is to 2 molar ratio, right? And then again, so you see the benefit of leaving as a fraction your question, the answers throughout. Remember, in calculations, chemical calculations, If it's a multi-step calculation, leave all the answers as fractions till the last stage. Otherwise, you round up here, you round up here again, third time final answer you round up, you get a different answer for the final answer. So don't round up till the last stage. You don't use the calculator till the last stage. So the ratio between we've found the moles of Fe3O4, and now you can find the moles of the Fe. You multiply this by 3, right? So moles of Fe 39.9 10 to the power 6 divided by 159.6, 2 times 2 over 3. We multiply this by 3. Why by 3? Because 1:3 ratio, right? You got the moles now, and you can find the mass of iron. You multiply the moles by the molar mass, right? And see, I'm just going to do it here itself because there's not enough space here. So the moles multiplied by the molar mass, you get the mass in grams. The question is all in tons, right? So divide by 10 to the power 6, you get the answer in tons. So you can see simply I can cancel it. So 39.9 multiplied by 55.8 divided by the 159.6. That's all. Yeah, yes. You get 13.95 tons in tons. Clear? Which of these solutions contain the greatest number of ions? First, let's find the moles of each, and then we break it into the ions. AQ equals, you get K plus, Cl minus, K plus, Cl minus. So likewise, you break into ions afterwards. Calcium 2 plus 2Cl minus equals calcium 2 plus 2Cl. So here you can see, you can't just say because the answer has to be C or D. We can't say because we don't know the number of moles. So let's quickly go through the number of moles. N equals CV. So 20 divided by 1000, volume in decimeter cube, and the concentration is 0.5. Here you have 20 divided by 1000 multiplied by 0.5. This is 0.01. Let me write the moles here. 0.03 divided by 1000 multiplied by, this is not divide by 1000. See, be careful. You divide by 1000 to convert centimeter cube into decimeter cube, because in N equals CV expression the volume should be in decimeter cube. So here you don't divide. So 0.03 multiplied by 0.4, get the answer as 0.012. So definitely when you compare A and B, A is greater. The B is greater because 0.012, early one is 0.01. So again here 10 divided by 1000 multiplied by 0.6. So here 6 10 to the power minus 3, which is 0.006, and 0.115. Here you don't divide by 1000 because the volume is in decimeter cube. 4 times 0.04, you get again 0.006. Now 0.006 is multiplied by 3. This is 0.006 again. Let me check again. 0.04 times 0.15. Yeah, 0.006. Earlier one, 0.6 divided by, multiplied by 10. This is, you get as, sorry. Yeah, this is, I think I divided by 1000 here. Yeah, that should divide by 1000. 10 divided by 1000 multiplied by 0.6, you get the answer as 0.006. This is 0.15 multiplied by 0.04, you get the answer as 0.006 again. So here the ratio is 1:2. So the total number of ions here is 0.02, right? 1:2. Here the total number of ions, you get 0.012. 0.012 times 2. This is total number of ions here, 0.024, and here 0.006 multiplied by 3. Why multiplied by 3? Because 1 mole gives 3 moles of iron. So this is both of these same answer, 0.018. So the highest value is 0.024, right? Yes, 0.024. So answer is B. Clear? Potassium, the next question. Potassium chlorate 5 decomposes on heating to form oxygen. What is the atom economy by mass for the formation of oxygen? That means the molar mass of oxygen divided by the molar mass of all the products or all the reactants. So the molar mass of oxygen will be 32, 16 plus 16 is 32, times 3. 32 times 3 is 96. That's the mass of oxygen, 96. 32 times 3 is 96. And then you divide by the molar mass of all the reactants or all the products into 100%. Doesn't matter reactants or the products because it's all elements are balanced, right? So you have potassium, but I just take the reactants here, 39.1, that is potassium. Chlorine is 35.5, and oxygen is 16 times 3 is 48, and that should be multiplied by 2. It is 245.2, right? So you can take all the products also, but it will be the same answer, 245.2. So 96 divided by 245.2 multiplied by 100, get the answer as 39.15, which you can take as 39.2. Therefore, answer is C. So percentage atom economy is the mass of the desired product. Here is oxygen divided by the molar mass of all. This is the molar mass of the desired product divided by the molar mass of all the reactants or all the products. So that's the end of the section A. The next is section B. This question is about the amount of water of crystallization in hydrated magnesium sulfate. Magnesium sulfate X-hydrate, hydrated salt. So what we do here is we step 1 says the crucible was weighed, a spatula measure of the hydrated magnesium sulfate was added, and the crucible was reweighed. Then you will know the mass difference. Will give you the mass of the magnesium nitrate, the hydrated one, which is present in the crucible. Crucible is a ceramic container which is used to heat. You want to heat a substance to very high temperature for a long period of time. You use these crucibles. The crucible containing hydrated magnesium sulfate was heated using the apparatus shown. After heating for 2 minutes, the crucible containing the magnesium sulfate was allowed to cool and was reweighed. Now, the thing is, this is a mistake done because the problem is, how do you know in 2 minutes all of magnesium sulfate loses the water of crystallization? We don't know. Ideally, you have to heat till you get a constant decrease in mass, right? So we don't know 2 minutes, well, it can be even 10 minutes. So you have to heat it, wait, heat it, wait until you get a constant mass, right? When all the water of crystallization is lost, then of course constant mass is obtained. And remember, you have to always take the mass, the weighing when the container is cooled, not when it's hot, because when it's hot, the heat waves will increase the temperature. So the results are given: empty crucible, mass of the crucible, and the hydrated before heating and after heating for 2 minutes is given. So you can see the mass is decreasing. So mass of magnesium sulfate after heating and the mass of water can be easily found. The mass of magnesium sulfate after heating for 2 minutes, that is 24.12 minus the empty crucible, you get the answer as 2.91, and the mass of water is a difference between before and after heating. So 26.71 minus 24.12, difference will be 2.59, and that is the mass of water lost. Those are the results to calculate the value of X in magnesium sulfate hexahydrate. So you need to have the mass of magnesium nitrate and water separately. So we got the mass of magnesium nitrate that is before heating, right? I mean the magnesium nitrate mass after heating, which is the anhydrous mass. The anhydrous mass is 2.91, and mass of water is 2.59, right? So this is the masses. You need to find the moles. With magnesium is 24.3, sulfate is 32.1, and oxygen is 64, and this is 2.91 divided by 120.4, and 2.59 divided by 18. You get the moles, and then you have to work out the simplest ratio to get the value for X. So 2.91 divided by 120.4 is 0.024, and 2.59 divided by 18 is 0.143. So divide both by the smallest value. Let's see, is these values we got, I think there should be some error with. Let's check on that again. Yes, that those values are correct. So you can divide by the smallest value. So get 1 is to 0.143 divided by 0.024. You get 1 is to 6. Roughly 6, 5.95 is 1 is to. So magnesium, 1 molecule of magnesium sulfate has got 6, is hexahydrate, 6 water molecules. The correct value for X is greater than the value calculated in A2. Because, you know, not reason is because we don't heat till a constant mass. Not all the water has removed, only limited amount of water is removed, right? Suggest a way of improving the method to obtain more accurate result using the same apparatus. Justify your answer. The hydrated magnesium sulfate should be heated till a constant mass is obtained. Constant decreased mass is obtained to ensure all the water is removed. So the answer for this, you can say 2 marks. To ensure that all the water is being removed, the salt should be heated to a constant mass. That's the first question. This question is about copper and its compounds. Complete the electronic configuration for copper and copper 2+. Starting from the argon configuration, that means up to 18. Argon is 18, so up to 18 is covered. Copper has an atomic number of 29, so you have 18 up to 3 P6, right? So 1s2, 2s2, 2p6, 3s2, 3p6. This is 18, right? So then I'm going to write the 3d. I'm going to fill the 3d up until 4s is filled. 4s2, 3d9, right? 29. Up to 4s2 is 20. 29, 29. We know 29 is not existing. D9 doesn't exist. D4 and D9 doesn't exist because they are unstable. Instead, what happens? An electron from the 4s level comes to the 3d level, right? Because you know, this is possible. This type of shifting of electrons are possible when the orbital overlapping takes place. You know, between 3d and 4s there's orbital overlapping, right? I would advise you to go through my study packs and the videos. If you have forgotten the theory on the atomic structure, I explain all this, right? And so this is 4s1 3d10. 4s1 3d10. It's not 4s2 3d10. And also your 4s level is filled first, and then you fill the 3d. Never write like this. You don't write 4s2 3d9 or 4s1 3d9. You don't write the 3d10. You don't write the 3d10 in the outermost. No. Filling order is you fill the 4s first because 4s level is below the 3d level, but after electrons are filled, the 4s level goes back to the high level. Right? So the copper 2+ will be 3d9. You remove 1 electron from the 4s and 1 from the 3d. Outermost electrons are removed first. A sample of copper contains isotopes copper 69 and 65. Complete the table to show the number of subatomic particles in the atoms of the 2 isotopes of copper. Proton doesn't change, it's 29 throughout. Neutrons is the difference, and the electrons is also the same as protons because isotopes on the neutrons differ. So 63 minus 29 will be 34 here, and 65 minus 29 will be 36. Number of neutrons differ in isotopes. That's why the isotopes have the same chemical properties, because the number of electrons are identical. explain the term isotopes using the information in the table. That means you can't say isotopes are atoms which has the same atomic number, different mass numbers. That answer is wrong here. You have to use the information in the table. That means you use a subatomic particle. So isotopes are the same number of protons and different number of neutrons. State why the two isotopes of copper have the same chemical properties, because you notice isotopes always have the same chemical properties because they share the same number of electrons. Right? Chemical property of the chemist is determined by the number of electrons. Relative atomic mass of copper in this sample is 63.4. Calculate the percentage abundance of the isotope 63 and 65 in this sample. You must show your working now. You know, when you add the percentages, it should be equal to 100, right? That means if I take 63 as X, copper 65 should be 100 minus X. We know chlorine. 35, 75, 30, 7 is 25. These values you to remember, especially for chlorine and bromine, you have to remember. Others you don't need to remember, right? So chlorine 35 is 75%, chlorine 37 is 25%, bromine 79 is 50, 81 is 50. So here, so you know the sum of the two isotopes will be 100. So relative atomic mass of copper is 63.4. That is equal to percentage abundance of 63, right? So 63 times X over 100 and 65 times X 100 minus X over 100. This is how you find the percentage, like we do for copper, the chlorine. 35, 75 over 100, 37, 25 over 100, right? So now you can solve this and get the value for X. Then you can work out the percentage abundance of the two, right? I'll skip the calculation part because that is time consuming. So you can do the calculation, straightforward calculation, get the value for X, and then you can find the answers for 2. Copper 2 sulfate can be made by reacting a solid copper 2 carbonate with sulfuric acid. Let me write the equation. So copper 2 carbonate reacting with sulfuric acid, you get copper 2 sulfate. This is carbonate reacting with acid, so you get carbon dioxide plus water. Make sure it's always balanced when you write equations, and state symbols are not required, so don't need to worry about it, right? So that's the equation. So always carbonate reacting with acid, you get salt, carbon dioxide plus water. An experiment was carried out to produce pure dry crystals of hydrated copper 2 sulfate pentahydrate. Copper 2 carbonate was mixed with 50 cm³ of 1 mole per decimeter cube sulfuric acid until no more reacted, right? So that means you are no more reacted means you are adding the copper 2 carbonate in excess, right? Sulfuric is limited. That's very important, because if you have excess copper 2 carbonate, you can easily filter off the solid copper 2 carbonate. But the problem is, accidentally, if you have, say, add excess sulfuric, that will be a problem, because your salt will be mixed with the acid. You can't remove the acid from the salt because both are solutions, right? So that's why we always, in forming crystal, during crystallization of a salt, we add the solid salt in excess, so you can filter it off at the end. The mass of copper sulfate pentahydrate obtained was 10.87 grams. Calculate the percentage yield for this reaction, giving you answer to an appropriate number of significant figures. So let's find the moles of the sulfuric first. N equals CV. 1000 contains 1 mole. That's the meaning of 1 mole per decimeter cube. 50 contains how much? You get 0.05 moles. Now we know the equation between copper carbonate and sulfuric. We wrote it before. Is 1:1, right? 1:1, right? So that means the number of moles of sulfuric will be the number of moles of copper carbonate, right? So moles of copper carbonate, CuCO3, also will be the same. And the moles of copper sulfate pentahydrate, look at that. That's also 1:1. Right? Copper sulfate is 1:1. So moles of copper sulfate also will be the same. 0.05 moles. So can't you find the mass of copper sulfate then? Moles into molar mass, right? So 249.6 times 0.05 is 12.48 grams. So to find the percentage yield, the equation is that the actual yield, that is what we got actually, over the actual yield is given in the question. This is expected yield, actual over expected into 100%. So actually how much you're getting is always less than expected. It's 10.87, see? 10 point, because of the so many reasons why you don't get 100% yield, but you're expecting 12.48, but I'm getting only to 10.87. Why? Incomplete reaction, transfer errors, mass loss during the reaction, so many reasons. So 10.87 divided by 12.48 into 100, we get the answer as 87.1%. So appropriate number of significant figures, 2 to 3 significant figures is sufficient. You can just write it as 87%, that's fine. 2 significant figures is more than sufficient. So 87 is okay as the answer. So that's the question 2 of section B. This question is about alkenes. Alkenes contain carbon to carbon double bond that consists of a sigma and a pi bond. Complete the diagram to show the areas of electron density for each bond. Label the pi and the sigma bond. This is what alkene. They're not specified, so this is a carbon-carbon double bond. You can see the electron density between. Now this is the sigma bond, right? And this is lateral overlapping of the p orbital will give you the pi bond. This is pi. This is one pi bond, not two pi bonds. This is one pi bond, and this is the sigma bond, right? Sigma bond. So the linear overlapping of the orbitals is, it can be hybrid orbitals, p orbitals. In this case, of course, hybrid orbitals. This is sigma bond, and lateral overlapping of 2 p orbitals here. It gives rise to one pi bond. So you can also show this this way, electron density in between, and like this. This is the pi, and that's the sigma. That's also correct. Propene is an alkene. The reagents needed for the 3 reactions of propene is shown. So first one is steam, reacting with steam, catalyst, and second one is acidified potassium permanganate, and this is bromine. They haven't specified whether it's bromine in water or bromine in CCl4. So that's important, but they haven't specified that. So steam plus acid catalyst is for the hydration. So you're simply adding an H and a OH across the double bond. So you have a H and a OH across the double bond. It's very important that you need to know which carbon gets the H and which carbon gets the OH here, right? So here, when this carbon gets the H, OH as a primary carbocation here, secondary carbocation is over here. That means if this bond breaks towards this carbon gets the positive charge. That's the primary carbocation. Sorry, the secondary carbocation, because the positive charge carbon is attached to 2 carbon atoms. See, if this bond breaks to this carbon over here gets positive charge, and if it breaks the other way around, then the first carbon, this carbon gets a positive charge. So which is more stable, primary or secondary carbocation, right? The secondary carbocation is more stable, right? Which is secondary carbocation? This carbocation, positive charge attached to 2 carbons. This is primary. Why secondary is more stable? Because positive inductive effect. 2 methyl groups are donating electrons, right? So the H comes here, then the OH should go there. Here, the H comes here, OH will come there. So the most stable carbocation is a secondary one. So the OH should go to this carbon, right? So I purposely wrote this answer here to show that why it is wrong, right? So you have to show the OH in the middle carbon. That's the most stable one, right? Since the marking scheme is not yet out at the point of this discussion, I'm not quite sure whether they are giving mass for the other molecule, which is a wrong molecule. Sometimes, if the majority happens to write that wrong answer, they might consider that as an alternative answer. So the correct answer is the propane 2-ol, where the OH minus will attack the most stable carbocation, which is secondary carbocation. As for the acidified potassium permanganate, just simply add 2 OH groups across the carbon-carbon pi bond. That's simply adding 2 OH groups across the carbon diol formation. And the bromine, likewise, simply add 2 bromine atoms across the carbon-carbon double bond. That's the bromination. If it is CCl4, we'll assume bromine is in CCl4. But if they say bromine aqueous, AQ, then again the OH minus will come to the secondary carbocation. Br plus will go to the primary. So OH will come here, Br. There will be OH and Br if it's aqueous bromine. Propene also reacts with hydrogen bromide. This is a very common question. The major product is based on the Markovnikov law. Again, the stability of the carbocation plays a major role here for the major product. Minor product is against the Markovnikov law. What the Markovnikov law states? Markovnikov law states that when hydrogen halide attacks an asymmetrical alkene, the hydrogen of the hydrogen halide attacks the carbon which already has a high number of hydrogens. So this carbon has 2 hydrogens and this carbon has only 1 hydrogen. So the pi bond will be broken towards this hydrogen to this carbon, and there's heterolytic fission over here. So this results in the formation of secondary carbocation. But if it breaks the other way around, then it's primary, which is not stable. So now the Br minus attacks this, resulting the major product, 2-bromopropane. The charges are very important here, right? And the arrows, when a bond is broken, the fully headed arrow is used to show the movement of a pair of electrons. When a bond is broken, you should start the arrow from the middle of the bond. You should point in between the atoms where the bond is formed. Bond is broken, then again middle of the bond and to the atom where the bond is broken too. And if a new bond is formed, you should start the curve from electron rich site towards electron poor. It should not point to the atom like this. This is not correct. It should be in between. It should be pointing in between the two spaces. Clear? Alpha oximine contains 3 carbon to carbon double bonds. It is found in plants and as a sweet smell. Skeletal formula of alpha oximine is shown. Skeletal formula don't show the carbon, neither the hydrogen attached to carbon. Give the molecular formula of alpha oximine. Now let's draw the structure here. You have a carbon, you got a CH, CH2, CH2, carbon, CH2, CH3. This carbon should always have 4 bonds. You can see here, this carbon over here has 1, 2, 3, 4th bond is hydrogen. 1, 2, 3, 4th bond is hydrogen. 1, 2, 3, 4th bond is hydrogen. So this is the formula, right? So here, can you check this carbon? 1, 2, 3, 4. It has already 4 carbons, right? So here, this carbon, let's check 1, 2, 3. There should be the 4th bond. So 1, 2, 3. Already there's 4 carbon bonds, right? There's no hydrogen here. So can you see 1, 2, 3, 4. So likewise this one, 1, 2, 3, 4. So how many carbons here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Where the line begins and line joins together, and where the line ends, there's a carbon, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons, right? Where line begins, where the line meets and the line ends, there's a carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. there's no shortcuts, you have to draw and see, right? So hydrogens, 2 plus 1, 3, 3 plus 3, 6, 7, 8, 9, 10, 11, 11 plus 5 here, 16. 16. So you might want to know, this doesn't follow the formula of CnH2n. It's alkene. It doesn't. Why? Because CnH2n is a formula for monosubstituted alkene. That means that alkene should only have one carbon-carbon double bond, not polyunsaturated alkenes. CnH2n is the equation, the formula for monounsaturated alkene. On the skeletal formula, draw a circle around a part of the molecule that gives geometric isomers. Geometric is cis-trans isomerism, or the EZ, and the condition is the presence of carbon-carbon double bond, and each carbon atom, right, should have two different entities attached to it. Look at this carbon. You have this whole group here, CH3 group on one end, so two different groups on this side. You have this whole group here and a hydrogen there, two different groups on the other side. So this shows geometric cis-trans isomers, but not these carbons, because these carbons are attached to the hydrogen, same element. So geometric isomers are shown by the corner one. Draw a skeletal formula of the other geometric isomer of alpha-oxymene. This is, what isomer is this, right? This is a priority group here. This is a priority group here, right? So what is drawn here is the priority groups on the, not the same side. Same side means in, we say same side. I always say as same side, right? Same side. So you have to refer the rules of priority order. You can go through my study pack 4B, right? You can get this study pack from the website chembaseacademy.com, right? This study pack under organic chemistry, you will notice the all the rules. This is geometric isomers, and then you have the first structural isomers, chain isomer, functional isomer, and the functional group isomers. And then you got the geometric isomers, cis-trans, EZ. Under EZ, I have mentioned the rules of assigning priorities. So you have to go through these rules, right? So the higher priority can be determined by various rules. There are 5 or 6 rules here. So I have explained all these rules in detail. So I advise you to go through that to identify which has a greater role. Here there is a carbon-carbon double bond. Whenever carbon-carbon double bond, we treat that as that specific atom is attached to that specific element twice, right? So C double bond O means carbon attached to oxygen twice. That's how we count it. So this molecule, I have to just shift the sides. That's all. I can shift either this part to the top or this side. So it's easy for me to shift this side because it's the shortest side. So I can shift this side like this and draw the rest of the molecule as it is, this way, right? So I have the priority groups over here, and bottom priority group, there's a hydrogen, but we don't usually show the hydrogens in a skeletal structure. It says skeletal formula, so hydrogen is not shown, which is hydrogen attached to carbon is not shown. So the priority groups on the same side meaning same side. So this is the other isomer, which is the Z isomer, which is drawn above is the E isomer. So usually we don't show, remember, the hydrogen. In experiment, 0.05 moles of alpha-oxymene reacted with 3.6 decimeter cube of hydrogen in the presence of a catalyst. Deduce the structure of the product of this reaction. You must show you're working. Let's first of all see how many moles of hydrogen is reacted with. You can find the moles volume over molar volume at room temperature. Molar volume is given as 24 decimeter cube per mole. So 3.6 divided by 24, get the answer as 0.15 moles of hydrogen. So let's look at the ratio. You have 0.05. This is the molecule, say A. You have 0.05 and hydrogen moles 0.15. So let's see how many carbon-carbon double bonds are there, because if there's one carbon-carbon double bond, it needs 1 mole of hydrogen. 1 mole of hydrogen contains 2 moles of atoms, right? So if you have 1 mole of carbon-carbon double bonds, or you say 1 carbon-carbon double bond, you need 1 hydrogen molecule, the 2 hydrogen atoms, right? So let's see how many hydrogen is utilized here, right? We have to divide this by 0.05, right? 0.05. You get 3, right? So that means 1 mole of this molecule alpha-oxymine needs 3 moles of hydrogen. 3 moles of hydrogen, right? That means 3 carbon-carbon double bonds have been hydrogenated, right? So how many double bonds are there? There are already 3 double bonds here. So all 3 are hydrogenated. All 3 get hydrogen. Structure of this, I'm going to draw the structure in this itself, right? Because just to save time, let me erase the previous answer. So simply what you do is just remove the double bond. That's all. Skeletal structure. Simply remove the double bond. That's all. Right. So while looking at this structure, let me draw it here itself, just to save time. So I can draw it like this. Same thing without the double bond. Right. Without the double bond. Here you have a single bond. This will be a single bond. This will be a single bond. This will be a single bond. That's all. Right, that's how you draw the product. Clear? That's question number 21. Clear? Before I move on to the next question, let me introduce you the point where you can get the past papers. You can log on to my website www.chembase.lk, and under materials you can click on past papers, and you'll notice the recent papers. You can download it. Some of the marking schemes are also made available, and all the locked papers can be obtained from this from my site. And also you can click on the online academy, or type chembaseacademy.com. There you will be directed to the academy, where you can purchase the recorded the videos of all the explanations. You can select your desired course, for in this case Edexcel IAL. You can click on IAL and you will see the past paper discussion for last 6 years, and also the rapid revision course and separate courses. Unit 1 past papers for last so many years, and Unit 2, Unit 3, like also rapid revision course is consists of entire a syllabus covered in few lessons. So that will be beneficial if you already follow the detailed course. So you can click on the Unit 1 course, and then the first lesson of each course is available free of charge. You can download the study packs for the relevant lesson, and then you can also watch the free video before you decide to purchase the course. This is the first one. Let me just play you that. So this is the first course, and you can notice the study pack is freely available. You can download the study pack. That is like a workbook where you have to write all the notes in that itself. So you can, this is a study pack, the very first study pack 1.1 is the first study pack of the first unit, which is chemical formulae, right? So you'll be getting the 10 study packs in this course, and the lessons, a video of nearly 38 hours of videos is available. That covers the entire Unit 1 of the IAS syllabus.
Hi everyone, welcome to Chembase Academy. This course encompasses a comprehensive discussion.
So let's continue the next question. This question is about bonding in the elements of period 3 or in the periodic table. The melting temperatures of period 3 elements are shown in the table. Now, in the melting and the boiling points are determined by their structure and bonding. So when it comes to metals like sodium, magnesium, aluminium, the melting point is determined by the strength of the metallic bond, which depends on the number of delocalized electrons and the size of the metal cation. The metal cation is smaller in size and it has a greater number of delocalized electrons. The metallic bond will be stronger. In that case, the melting and boiling point will be greater. And because the silicon is a giant covalent structure, just like diamond, each silicon atom has 4 covalent bonds around it. So the boiling and melting point of silicon is determined by the strength of the covalent bond. So it is extremely high because melting silicon requires breaking of 4 covalent bonds around it. As for phosphorus, sulfur, chlorine, they are simple covalent molecules. In simple covalent molecules, the melting and boiling point is determined by the strength of the intermolecular attraction, not the strength of the covalent bond in simple covalent molecules. So sodium, magnesium, aluminium are metal. State what is meant by metallic bonding. That is the electrostatic attraction between the bonding pair of electrons and the nuclei. So electrostatic attraction between the metal cations and the delocalized electrons is referred to as the metallic bond. Melting temperature depends on the strength of the metallic bond. Explain why metallic bonding in magnesium is much stronger than in sodium, because magnesium has a smaller cation radius than sodium, right? Sodium is large, magnesium is small, and also magnesium has a greater charge than the sodium. So greater charge, smaller cation, and number of electrons in the sea of delocalized electron is greater in magnesium than in sodium, because each magnesium atom donates 2 electrons to the sea of delocalized electrons, whereas sodium donates only 1 electron to the sea of delocalized electrons. So you can mention that magnesium has more or greater number of delocalized electrons than sodium does. That's one of the points. Then you can say magnesium has a greater charge of the cation than sodium and also smaller size. We can in short say greater charge density. So as a result, magnesium has a greater electrostatic attraction towards the electrons, resulting in stronger metallic bond. In the elements silicon, phosphorus, sulfur, and chlorine, the atoms are joined by covalent bonds. Describe the attraction between the atoms in a covalent bond. A covalent bond attraction between the atoms. The nuclei of the atoms will be attracted, or the shared electron pair is attracted by the nuclei of the atoms. The shared electron pair is attracted by the nuclei of the atoms in a covalent bond. Explain why melting temperature of silicon is much higher than that of phosphorus, referring to their structures. Phosphorus is a simple covalent molecule which exists as P4 molecules. There are weak attractions between the phosphorus molecules. Whereas in silicon, each silicon atom is bonded to 4 other silicon atoms by single covalent bonds. It's a giant structure just like diamond. So melting silicon requires breaking of these all 4 covalent bonds around each silicon. So that requires a lot of energy. So you have to mention first of all, phosphorus is a simple covalent molecule with weak intermolecular attractions. We get dispersion forces here because they are non-polar molecules. Dispersion London forces. Whereas silicon is a giant structure where each silicon atom is tetrahedrally linked to 4 other silicon atoms by single covalent bonds. Therefore, a lot of energy is required to break these bonds, and that's why silicon has an extremely high melting point. Sulfur reacts with chlorine to form sulfur dichloride. Complete the dot and cross diagram of a molecule of sulfur dichloride. Adduce dots for the chlorine and crosses for the sulfur electrons. It's beneficial if you go to the Vesper theory, that for the shape of the molecule, and the Lewis theory. It is important because the Lewis theory is known. You can easily work out the structure of any complex molecular ion. These are of course simple molecules, but even if you come across a complex molecule, you can easily work out their structure and their shape using the Lewis theory and the Vesper theory. This is covered under the chapter of chemical bonding. So chlorine dots. So you have 7 electrons around chlorine. Right. Let me move this a bit. Yes. 7 electrons, so 1 electron bonding with sulfur. Electrons are in pairs. And sulfur has, just like in oxygen, 6 electrons, 2 electron pairs. It's angular molecule because 2 electron pairs repel the bond pairs, resulting in angular shape. Just a value for the chlorine sulfur chlorine bond angle. So this is angular, and the basic shape is tetrahedral. Remember, not the shape. Shape is angular. The basic shape is determined by Vesper theory. This is all covered under unit 3. Vesper theory is lone pairs plus the bond pairs. 2 plus 2 is 4. That is tetrahedral. But the shape is not the basic shape. The shape will differ from the basic shape if the central atom has lone pairs, right? So shape is angular. Shape is angular, right? So what's the bond angle? Tetrahedral is 109.5 degrees. For each lone pair, you deduct 2.5. For each lone pair, deduct 2.5, right? So here, 2 lone pairs, so deduct 5. You get 104.5 degrees, right? That's the bond angle of the angle. Not always angle is 104.5. You can't memorize those values like that. Basic shape values you need to remember. Derivatives depending on the number of lone pair. For example, basic shape is, say, trigonal planar. If there's a lone pair in the central atom, right? Say this is a basic shape. Say this is central atom, terminal atoms. This is trigonal planar, right? There's a lone pair here. This is angular now. Lone pair repels the bond pair. But now this angular is not 104.5 because basic shape trigonal planar bond angle is 120, right? So 120 minus 2.5. This is 117.5. This is angular. So you can't say angular is 104.5, memorize and go. No, that's not possible, right? So you derive the basic shape on the lone pairs and the bond pairs using the Vesper theory. You can use the basic shape and you derive the shape. If a central atom has lone pairs, then you have the derivative shape, in this case angular. Each lone pair deduct 2.5 from the basic shape. Just to remind you, this is under structure and bonding. Towards the end, I have given in my notes, towards the end, the Vesper theory and the Lewis theory. There are 5 rules there. It's because of a polarization and all those here, right? The 5 rules, let me go through that. Yes, this is the Lewis theory. You can derive the structure of any complex ion or molecule, and then the Vesper theory is mentioned towards the end to determine the shape of the ion or molecule. So here I mentioned about the molecular distortion and how to determine the boiling point without memorization, because you have to minimize memorization, maximize understanding if you need to excel in this subject. Right, so what you should write here, you should say sulfur dichloride has 2 bond pairs and 2 lone pairs on sulfur. Lone pair repels, as well as a lone pair bond pair repels. So lone pair repulsion is greater than the lone pair bond pair repulsion. Therefore, in order to minimize the repulsive force, the lone pair repels the bond pair, resulting in angular shape. That's question 22. Next question. This question is about ionization energies of elements in period 2 of the periodic table. Period 2. Across the period, the energy of ionization increases generally because size decrease. The effective nuclear attraction increases because of that. The size decrease and constant shielding effect. You'll see anomalous increase in beryllium and nitrogen. That is because of the boron is in P1 state here. P1 is quite away from the nucleus, so slightly less energy. And oxygen is in S6 here. Sorry, this is the P orbital. P4. So P4 has, as to the Hund's rule, we know there is a pair of electrons in P4. That's repels. So repulsion, when the electron pair repels, easy to remove the electron. That's why it's slightly lower in oxygen. Anyway, give you the equation. Let's sometimes you might get that question as explanation as a question. Let's see. Give an equation that represents the first ionization energy of lithium. Include the state symbol. So from gaseous lithium atom, you remove 1 mole of electrons to form 1 mole of gaseous lithium ion. So first ionization energy is defined as energy required to remove a mole of electrons from a mole of gaseous atoms to form a mole of unipositive gaseous ions, all from the gaseous state. Explain why there's a general increase in the first ionization energy across the period. That is because across the period the size decreases. Why size decrease? Constant shielding effect. Number of shells are equal. Number of shells determine the shielding effect. Constant shielding effect, and the electrons are drawn more and more closer towards the nucleus. So as a result, more energy should be supplied to remove the electrons. Right? That's the reason why the energy of ionization increases across the period. So you can say across the period from left to right. It's very important to mention left to right. The atomic radius decrease due to constant shielding effect and increase nuclear charge. As a result, electrons are drawn more closer towards the nucleus. Hence, it's difficult to remove electrons as the effective nuclear attraction increase across the period. Now the question explains why the first ionization energy of oxygen is lower than that of nitrogen. Oxygen and nitrogen. Let's write the configuration. Right? 1s2, 2s2, 2p, right? 3. Oxygen 1s2, 2s2, 2p4. So p3, as to the Hund's rule, electrons in the p orbital are singly occupied. p4, electrons 1, 2, 3, 4, doubly occupied. Right? So when electrons are doubly occupied in oxygen, in the p orbital, it's easy to remove the electron because there's a repulsion. Electrons are in pair, there's a repulsion, therefore it's easy to remove the electrons. So first try the electronic configuration and say the electrons in the p3, nitrogen electrons are in the p3 form, there's no repulsion, but the electrons in oxygen is in p4 form as electron pair, and there will be repulsion between the electron pair. That makes the electron to be removed easily. All the successive ionization energies of nitrogen are shown in the table. Successive means one after the other you remove the electrons, right? You can see there's a huge increase, large significant increase between the 5th and the 6th. And that's the first increase. That means like this. You have 3, 4, 5, 6th and 7th. There's a huge increase. We know before the first large significant increase, the number of points corresponds to the number of electrons in the outermost shell. This is the outermost shell. This outermost shell contains 5 electrons because that's why you get 5 points. Between the 5th and the 6th, there's a huge increase. That means this 6th electron is removed from the inner shell. So there will be, this belongs to group 5, and it has one significant large change. Therefore, 2 shells, period 2, group 5. Explain the trend in successive ionization energies of nitrogen. You can say the first 5 electrons are removed, or you can say the first 5 electrons are present in the outermost shell. Removed from the same shell, you can say. There is a huge increase between the 5th and the 6th ionizations. This is because the 6th electron is removed from a new shell which is closer to the nucleus, completely filled new shell which is closer to the nucleus. Therefore, huge energy should be given to remove that. Right? That's the question 23. Yeah, we got, I think, 24. That's the last question to go. This is the gas law, PV equals nRT calculation. 0.210 grams of sample of volatile organic liquid C is injected into gas syringe and heated in oven 100 kilopascals and 358 Kelvin. The syringe contains 72.5 cm cube of a gas. The most important thing is before you start applying PV equals nRT, you need to know the units of these. The pressure is given in pascals, right, which is Newton per meter square. In my theory lesson, I explained how to convert ATM to Newton per meter square. That is multiplying by 101,325 Newton per meter squared equals 1 ATM. So in case if you are given in ATM, you have to multiply by this value to get in Newton per meter squared. Volume has to be in meter cube. So if you have the volume in a decimeter cube, you have to multiply by 10 to the power minus 3 to convert into meter cube. If it is in a centimeter cube, then 10 to the power, decimeter cube into meter cube 10 to the power minus 3, and centimeter cube to meter cube 10 to the power minus 6. Right? This is easy. If you, so in case if you forget or get confused, remember this: 100 centimeters, 1 meter. This is from this grade. This from grade 2, right? So what you do is you cube it, cube the both sides. So you have 1000 times 1000 centimeter cube, 1 meter cube, right? Which is 10 to the power 6 centimeter cube is 1 meter cube, right? So 1 centimeter cube will be 10 to the power minus 6 meter cube. So if you have in centimeter cube, you have to multiply by 10 to the power minus 6 to convert it to meter cube. And also from this point, you can say we know 1000 centimeter cube means what? 1 decimeter cube, right? So you have 1000 times 1 decimeter cube equals 1 meter cube. So 1 decimeter cube equals 10 to the power minus 3 meter cube. So this is how you convert. In case if you forget, so just remember this: 100 cm, 100 centimeters is 1 meter, right? So this is important because you have to do some conversions. Temperature has to be in Kelvin, because the R is given in joules per mole per Kelvin. So Kelvin should get cancelled. Moles per mole get cancelled. So it's very important that RT has to be in Kelvin. So the pressure, let me just substitute the values now. So pressure is given in kilopascals. Let me just erase this. Right. So kilopascals, you multiply by 1000, you get in pascals, because you have to have the values in pascals, right? Not in kilopascals. So you have to just simply multiply that by 1000 to convert the kilopascals to pascals. Let me just write it here. And then the volume you have to convert. So this is pressure is 100 times 1000. Always substitute with the unit, so you'll not do any mistakes. This is times 72.5 10 to the power minus 6 meter cube equal to N is a number of moles. So we don't know the moles, we know the mass, 0.21 over molar mass, right? R is 8.31 and temperature is given in Kelvin, 358. So moles I took as mass or molar mass, right? So you can see whether your units get cancelled now. Pascals is Newton per meter squared, right? And here you have Newton per meter squared. This is meter cube, this is moles, and you have joules per mole per Kelvin, and temperature in Kelvin. So per Kelvin, Kelvin cancels, right? Per mole cancel. Newton per meter squared and meter cube is Newton meters, which is joules. So this is how the units are very important. So you can solve this, right? I'm not going to do the calculation part just to save time. I just explain the method. You can calculate and get the value for the molar mass of the gas. The organic liquid C is a hydrocarbon. Give a possible name or formula for C using your answer in A. That you need to know the molar mass for that. Then you know the hydrocarbon. We can easily work out the formula of the hydrocarbon if you know the molar mass. So let's work out for that reason. So this is, you get 7.25, and you have at this side of the equation, and the other side 0.21 multiplied by 8.314 multiplied by 358. On this side you got 600 25.04, and the molar mass is over here. So molar mass equals 625.04 divided by 7.25, to get 86.21. So roughly we take as 86. So let's see which hydrocarbon. A hydrocarbon is it says volatile organic liquid, right? So and it says hydrocarbon. So to say hydrocarbon, which hydrocarbon has a mass of 86? So you can write the homologous series and determine. So let's start with C6H12. You have 12 times 6 plus 12 equal to 784. So it can't be C6H12. It can't be alkene. So obviously it has to be an alkane. C6H14 is 86, right? So the molar mass we got as 86 in the previous. So it has to be C6H14. Remember, you can't say this is hexane because we don't know the structure of it. It can be a branch isomer, we don't know. So we don't name organic molecules by simply looking at the molecular formula. We need to know the structural formula for us to identify the name. Right, so that is a final question. So with that, we conclude, and we've completed the entire paper of the recent. Just to remind again, at the point of this discussion, the marking scheme for this paper is not yet out. Please do subscribe to our channel to get future further updates like this, and please do visit our website kimbase.lk for the recent past paper. You can download this paper from the site, and also kimbaseacademy.com for the course. If you need to follow the theory lessons, you can simply watch the videos, the sample videos, and go through our courses. So I wish you all the best for the upcoming exams. And also, if you have any questions, you can write to me at info@kimbase.lk, or email address info@kimbase.lk, or you can simply drop a message. You can go to Kimbase Academy and you can have the WhatsApp option there. You can drop a message whenever time permits. We'll attend to your doubts and questions. So hope you enjoyed this discussion, and let's see you next time.